Most people meet an NTC temperature sensor only when something they rely on starts behaving strangely. The fridge no longer keeps milk cold, an espresso machine never reaches brew temperature, or a combi boiler flashes a code that forbids the shower. The little bead or probe at the heart of that drama is a thermistor whose electrical resistance drops along a precise exponential curve as it warms, allowing the control board to translate resistance into a real-world temperature reading with surprising accuracy. Engineers like the classic 10 Coulomb Beta 3950 curve because it is cheap, stable, and easy to linearize, which is why you find it embedded in appliance walls, clamped to pipes, glued inside 3D printer hot ends, and lurking inside flue pockets. When moisture seeps into the encapsulation, when wires fatigue, or when a dab of thermal compound dries and cracks, the sensor can drift so far that the controller thinks a room temperature chamber is already frozen, or that scalding water is still too cool. The consequences of that tiny fault feel bigger than the device itself. A refrigerator with a sick thermistor may short cycle the compressor every 60 seconds, never reaching 4 degrees and spoiling food, as countless repair videos like the one from Appliance Parts Pros demonstrate. A domestic boiler, fooled by an open circuit sensor on the return line, locks into a safety mode and shows the dreaded E20 until the part is swapped, a scenario you can watch play out on a backseat combi in plumbing tutorials. Even hobby electronics are vulnerable. A 3D printer that thinks its hot end is cold will drive the heater to the limit and may trigger thermal runaway protection. These real-world frustrations remind us why spending 10 minutes to replace an NTC is worth it. Before the first screw is loosened, absolute safety rules apply. Disconnect mains power or trip the breaker, and on anything that contains pressurized fluid, espresso boilers, sealed system water heaters, or hydraulic PID coffee machines, bleed off pressure and allow metal to cool below a gentle hand touch. Professional repair guides for refrigerators spell out the same essential routine. Unplug, clear space, wait until things are at room temperature. Soldering instructions from TDK go further, specifying no more than 4 seconds of contact at 260 degrees Celsius and a 6mm distance between the iron and the ceramic body, because invisible microcracks born during rough handling can change resistance enough to confuse the appliance even after the fix. Respecting those limits turns a chore into controlled, repeatable work rather than a gamble with live circuits and steam burns. With the power off and the cabinet open, follow the twin leads or thin harness until it disappears into a pocket, a clamp, or a smear of white paste. While the form factors differ, flat tabs screwed to a fridge liner, stainless probes threaded into a brass boss on a boiler flow pipe, glass bead micro sensors soldered straight onto a controller board. The electrical personality must match the original. Check the rating printed in the service manual or on the old part itself. Most domestic appliances rely on that ubiquitous 10 coulombs at 25 degrees Celsius. Beta equals 3950 kiloparsecs profile that appears throughout Vichy's catalog. But some commercial systems use 47 coulombs or 100 coulombs elements for finer high temperature resolution. Substituting a part with the wrong room temperature resistance or beta value will shift every reading the control board makes, sometimes by tens of degrees, so ordering any thermistor that physically fits is not good enough. Removing a failed sensor looks simple, but rewards patience. If it lives in a pressed-in plastic clip, tease the clip open with a plastic tool so as not to scar insulation. If it screws into metal, back the thread until the O-ring relaxes, then twist the body gently to break the dried compound's grip before pulling. Board-mounted beads require a steady iron, and the TDK soldering limits you heard a moment ago. Keep the tip clean, apply fresh solder for heat transfer, and lift the lead without levering. Once the sensor is free, prove the diagnosis at the bench. Switch a multimeter to the 20 coulomb range, touch the probe tips to the leads, and read the value. At 25 degrees Celsius, a healthy 10 coulomb part reads close to its nominal resistance, and the mere warmth of your fingers should drag the number steadily down. An open circuit, a reading far from spec, or a value that barely moves under heat confirms the replacement was necessary. The new sensor arrives with bright tinned leads and often a tiny sachet of silicone-based thermal grease. Many first-time fixers wonder whether that gray or white paste matters. Application notes from the HVAC industry explain that even a hairline air gap between the probe and its metal well acts like insulation. A paper-thin smear of non-conductive grease chases out the bubbles and restores rapid thermal transfer. The layer should be so thin it almost seems wiped away. Slide the probe until its shoulder seats. Finger tighten any retaining screw, then add a cautious quarter turn with the driver. Route the cable so it floats boats clear of fans and hot surfaces, and secure the harness with clips or a tie where the manufacturer had one. Nitpicking here means the fresh leads will not chafe or vibrate themselves loose during years of thermal cycling. Validation closes the loop and lets you trust the repair. Keep covers off, re-energize the appliance, and if it offers a diagnostic mode, watch the live temperature readout settle close to room conditions. A fridge may run its compressor briefly, then pause while the main board rescales. An espresso boiler might idle until the PID calls for heat. Compare the controller's reported temperature with the multimeter reading still connected across the sensor harness. Within 2 degrees is excellent agreement. For water heaters and boilers, step the set point upward in small increments. The displayed value and the resistance to temperature conversion you measure should climb in lockstep. If the readout races ahead while resistance lags, suspect poor thermal coupling. If the resistance plunges while the readout crawls, the fault may have moved upstream to the control board. Manufacturer bulletins remind technicians to run a full heating cycle and verify that fault codes reset themselves before buttoning up the shell. Once every test passes, restore panels, shelves, and covers, then take a minute for future proofing. Write the installation date, the resistance rating, and the supplier's part number on a small label hidden inside the service area. Proper electronic waste rules say the failed thermistor belongs with discarded circuit boards, not the kitchen bin, because the epoxy bead traps metal oxides that should stay out of landfill. Finally, let viewers, or in your case listeners, enjoy the quiet satisfaction of an appliance regulated once more by a sensor that understands the language of temperature as precisely as the day it left the factory. That calm whir of a fridge compressor idling at the right moment, or the steady thrum of a boiler firing only when needed, is the audible proof that 10 careful minutes and a matchbook-sized part have restored control.